Okay, this is number 53 in your homework. It's a strong curve. I have 0.2 molar HCl4 in the beaker, and I have 40 milliliters of it. And I'm adding to it 0.1 molar KOH. Looking at this, I see this is 0.2 and this is 0.1. So the base is half as strong as the acid. So I'm going to need twice as much base than acid to reach equivalence. If you can't see that by looking at it, you would do 0.04 liters times 0.2 equals 0.1 times X, and you'd solve for X, and X has to equal 0.08. Okay, so I know that the equivalence point is going to happen when I have added 80 milliliters of the base. So now I'm ready to begin. It says, what is the pH when you've added 0 milliliters? So it's only HClO4 present. We can assume 100% dissociation, and we're going to have 0.2 molar because it was 0.2 molar in the beaker. And the negative log of 0.2 is 0.699 is the pH. I didn't assign 10 milliliters, but it's easy to do 10 milliliters. We know that the base will react with the acid, and it's going to make KClO4, which is a neutral salt. So in the strong curves, you really don't care about anything besides the OH and the H+, because this will not affect the pH. It's neutral. So we take the molarity times the liters to get the moles of each of the substances, and we know we're going to lose all of the base because it's before equivalence. We'll be left with 0.007 moles. We need to divide by the total liters. So 0.007 by total liters is 50 because we have 40 milliliters in the beaker and we add to it 10. When you do that, you'll get the molarity, which for 10 milliliters added should be 0.14, and the pH should be equal to 0.854. Okay, so total volume sometimes tricks people up. Now we want to do when 40 milliliters are added. So we pretend like each time we're referring to just the beaker. We're not saying, okay, this is left after 10, so take this and 30 milliliters from that. That's a lot more complicated. We're just going to start back over again. When 40 milliliters, we have this in the beaker, and we have this being added. Okay, so we have 0.008 in the beaker and 0.004. I can tell that that's halfway because I have half as much base as acid. So you'll subtract it out. We'll have 0.004 left over. Divide by the total volume, which would be 40 plus 40, so 0.08 liters. And we get a pH of 1.3. Okay, at 80, which is what I determined to be the equivalence point, we can prove that it's the equivalence point because we would have 0.1 times 0.08, which is this number, 0.008. We'd have 0.2 times 0.04 in the beaker, so we get 0.008. You subtract those two things out, and we end up with 0 of both of them. So the only thing in the beaker is the water, which has a pH of 7. And after equivalence, they gave us 100 milliliters. So we again pretend like we're starting all over again. In the beaker, there's 0.008 moles. And being added is 0.1 times 0.1, so 0.01 moles. Now we have more base than acid, so we will subtract out all the acid, and we will be left with 0.002 moles of base. Divide by total liters would be 100, plus 40 would be 0.14 liters, which gives you 0.014 molar, which I believe is correct. And when you calculate that, POH is 1.85 and pH is 12.15. And then, of course, you would just graph base added and pH, and you would get something like this. Okay.